Hi everyone, I'm Cheryl. In this problem, we're looking for the center of mass of a planar lamina. Now what's interesting about this particular problem is our answer is going to be different depending on where we put our Cartesian plane. In this example, I've decided to put the y-axis straight through my geometric shape and have the shape sit right on top of the x-axis. All right, so the next thing I want to do is start finding the pieces for that center of mass. Well, I'm looking at this particular lamina and I notice that I have three rectangles. The top rectangle, a middle one, and also a bottom one. To find the center of mass, what I'm going to do is find the center of mass of each of the individual rectangles and use those as mass points to calculate the overall center of mass. So, finding the center of mass of a rectangle is actually a very easy thing to do. You're just finding the middle of the rectangle. So on my top rectangle, it's going to be located right at that point. And the ordered pair associated with this point is going to be the point 0. And notice it's at 7.5, so that will be at 15 halves. So that's the centroid, or the center of mass, for that top rectangle. For the middle rectangle, again, the center of mass is going to happen right at the center, which is going to happen in this case right here. The x-coordinate is 0, and notice that the y-coordinate is 5. In my bottom rectangle, again, the centroid, or the center of mass, will happen right in the center, which will happen right here. The x-coordinate will be 0, and the y-coordinate 3 halves. Okay, so now what I have is I have three different mass points that I can use to calculate the center of mass for the overall lamina. Okay, so what I'm going to do next is I'm going to calculate the area. So the area of each of the individual rectangles will be 7 times 1 for the top rectangle. The middle rectangle is going to be 4 times 3. And for the third rectangle, or the bottom one, it'll be 3 times 5. And with a little arithmetic, I get 7 plus 12 plus 15 for a total area of 34. Okay, now I need to find the x-coordinate of my center of mass. Now remember, what I'm going to be doing is I'm going to be taking the area of my top rectangle and multiplying it by the directed distance from the y-axis. And the directed distance from the y-axis is 0. So I'm going to have 7 times 0. Then I'm going to take the area of my middle rectangle, which is 12, and multiply it by the directed distance from the y-axis, which is again 0. I do the same thing for my third rectangle. The area is 15 this time, and the directed distance from the y-axis is 0. It takes very little arithmetic to see that that's going to be 0. Although I've got one other thing I should point out. This is not actually x bar. Remember, you have to divide that whole quantity by my area, which is 34. But luckily that doesn't change the answer. It's still 0. Okay, let's try the y value. This time I'm going to be taking the area of the top rectangle, which is 7, and multiplying it by the directed distance from the x-axis this time. So the distance from here up to here, that's the y-coordinate, or 15 halves. Now I add that to the area of my middle rectangle, which was 12, times the directed distance from the x-axis, which this time is 5. Then I add that to the area of my bottom rectangle, which is 15, times the directed distance from the x-axis, which is 3 halves. And again, don't forget, we need to divide this by the total area of 34. Okay, now you're going to want to pull out your calculator and do some calculations. So if you multiply 7 times 15 halves plus 12 times 5 plus 15 times 3 halves and divide the whole thing by 34, you're going to end up with 135 all over 34, which is approximately equal to 3.97. So what does that tell you? Well, it tells you that your center of mass of the entire lamina, x bar, y bar, is going to be equal to 0 and 3.97. Let's take a look at this on my picture. The x-coordinate is 0, and the y-coordinate is 3.97, which is almost at 4. So that makes this point the center of mass. Hope that was helpful. Thanks.